Right, my name is Owen Davies. That's a picture of me. I'm smiling, so it probably means I'm drunk. That is my website. I don't have a Twitter account. I guess I'm not hip enough. But on there you will find these slides in case there's anything too small, and also the GitHub repository, which is kind of my local home project for testing out new things. It has a few of the things I'll be talking about in. It's not a particularly complex project, so there's not too much to it, but it does have a few examples in. Currently I work for Big Sofa. We don't sell sofas, it's actually a video research technology company. And yes, unfortunately we're not actually hiring at the moment, but hopefully soon we will be hiring a SysOps, DevOps kind of person, so keep an eye on them. And I will be talking about Puppet Contained. So very quickly, just to make sure I'm not wasting my time, hands up who knows about or has heard about Vagrant. Okay, high number. How many people are using it actively? Okay, probably about 20%. Yes, it was mentioned earlier as well. And secondly, another thing that's been mentioned a couple of times through the day is Docker. Who knows about it and knows what it is? Again, pretty much everyone. And who's actually using it actively? Far fewer, probably about 5%. So yes, they're both, well, Vagrant's actually quite an old technology now, but still not used everywhere. Docker is a very new technology and is moving quite quickly at the moment. Also being talked about quite a lot, I guess. So, first off, I'm going to cover Vagrant, and its website says it very nicely. It's development environments made easy. I actually like the fact it's really easy to download and get set up. So many open source projects are absolute pain. So, yes, go to the website, download the software. And the second component to it is VirtualBox. This is the default environment it uses for spinning up development environments. It does support VMware, other provisioners as well, but VirtualBox is its default. So, easiest way to show you what VirtualBox does is to show you from their demo page how to use it. So, create a new directory, go into the directory, do Vagrant in it with a default OS or image. So here we're going to just be using Ubuntu, and it creates a file, tells you where it's putting it, and then type Vagrant up. And what that gives you is, if we go into VirtualBox, you'll see the highlighted server there is a virtual machine running Ubuntu in VirtualBox. So this is extremely nice, and it's obviously not a Vagrant talk this, but basically, if you've not used it before, it gives you a very nice, easy, self-documented way of setting up virtual machines. If we have a look at the actual file it creates, so the first step actually is it caches everything. So if you were to create another dev machine, it's already got Ubuntu downloaded, so you don't have to re-download that. It deals with lots of things nicely out of the box. So the default Vagrant file basically tells you an awful lot of the things it can do. Rather than having to go into virtual machine and configure everything, it sets up everything itself. It can do networking, basically everything else you would do with a virtual machine. Because it's all stored in a file, it's easy to check in as part of your repo, and it makes it an awful lot easier for developers to set up a new dev environment. So this is basically what's in that first file that's not commented out. I want a box, and I want it to be based off Ubuntu. So I think one of the first things that's actually very useful I've found with VirtualBox is it creates by default a shared folder with your repository on your local file system. So by default out of the box, it's very easy to use GUI editors, especially when I've worked at companies where you have designers who maybe aren't good with command line. It gives them an easy out-of-the-box way of doing this, especially trying to set up NFS and shared files, folders between a Mac and Linux is always a bit of a pain. This just does it out of the box, so people can use their default editor on the Mac as if they were just using a locally run project. One little gotcha about this, which I probably think should be documented out of the box, is most people use Ubuntu virtual machine with VirtualBox, and Git repository. By default, it uses the VirtualBox's built-in shared folder system. That works fine if you've got a few hundred files, but if you've got a few thousand, say in a Git repository, it goes really slowly. So if you do Git status, it just doesn't, it takes ages. So by default, basically this is saying set up a private network, which is also then useful for being able to view, say, running servers on that virtual machine. And then also change the /vagrant, which is the kind of default shared folder with the repo, to use NFS. So then that's a lot quicker and will work. And it's kind of annoying it's not just out of the box, that one. So, moving on very quickly. Vagrant has lots of different provisioners, and here we can see a shell provisioner, which if you've only got a small little project, great, you can see, okay, I want to do an apt update, and I want to install Ruby on this VirtualBox. And then that gives someone very nicely out of the box using VirtualBox, Ruby. So, don't get angry, we're not having to go back to shell scripts. It also does support out-of-the-box Puppet, which is, obviously here, extremely nice. This is also especially useful, say for example, you've already got a lot of Puppet configuration for your production environment, and you're wanting to create a dev environment that's going to be easy to set up and as like to your production environment as possible. So, by default, all you need to do is say, use Puppet, and then create a default.pp in a manifest folder in your project. And say, here we go, let's install some packages. You can then check that all in, and it also means that everything to do with this project is now within the project. You don't have to be going around getting other things to set up your dev environment. You just download your repo, spin up Vagrant, and you have everything. So, we can then start to configure this. There's an awful lot of Vagrant options, and there's a lot of documentation online. The Vagrant documentation, again, is extremely good. So, for example, here, it might be nicer, for example, to keep all your Puppet stuff together in one folder rather than interspersed amongst your Ruby or Python code. So here I'm just configuring that the manifests will be in Puppet manifest, module path. Say I have multiple module paths or something. And again, our nice little NFS shared folder thing comes up, so just configuring that. So I said about the documentation. Again, yes, so there's plenty of documentation about Puppet apply. There's all sorts of options. It integrates very nicely into Factor that we heard about earlier. So if any of your environment variables are, say, configured via Factor for your production environment, you could put different configurations in for your development. For example, host name, or whether to use SSL certs, etc. And there's plenty of options there. You can also have a Puppet agent provisioner again. So if you're running a Puppet master slave kind of system, then you can just, again, configure your Vagrant just to connect, and it will have all the configuration options and the SSL certs and secrets options all here. When you do Vagrant up, your VM will just connect straight to your Puppet master, and using as normal will be able to just provision itself. So again, all very just out of the box, and the developer won't have to worry about this too much. So the next bit I'm just going to detail is Librarian Puppet. Quick show of hands again. How many people have heard of Librarian Puppet? So probably only about a third, and out of those, how many people use it? Again, about 5%, not many. Librarian Puppet is basically a copy of the system that Ruby uses for installing library dependencies called a gem file. And it's basically a nice file for configuring how you're going to install your dependencies, so your various modules off Puppet Forge or any other places. Say, for example, you have self-hosted modules that are private. It's quite a nice tool. You package in the version. You can say specific versions in this file if you want. It will also create a lock file so that you don't just have random versions installed every time you install your software. And it will also, you can easily then update things. It takes over the modules folder. So you can't then go around editing modules you've got from the Forge and not realise which ones are Forge modules, which ones aren't, and also make things very easy to update. And even if you're not using Vagrant or any of these other technologies, I'd recommend looking at Librarian Puppet for managing modules. So here we can see I'm just getting from the Puppet Labs Forge, I want RBM, Postgres, and Vim. So if we go back to our previous example with our default PP, it means very quickly I can get set up using a dev environment. So I want, say, RBM, I want to, using the Forge module, I want those packages installed, and I want my Postgres client and server. So lots of nice stuff for a Ruby developer to use there. So unfortunately, Librarian Puppet isn't part of the default Vagrant or part of Puppet by default. So we do have to use a little bit of shell stuff to get that installed, ready for then running Puppet. So you can see this basically installs Ruby, installs Librarian Puppet gem, so it's just gem install Librarian Puppet, goes into the Vagrant Puppet directory and runs Librarian Puppet install that will then either pull down all the modules from the Puppet Forge, or you can also package modules with Librarian Puppet into the repo in a cache, so then you don't have to be reliant on an internet connection or other kind of problems like that. And then, as before, then our Puppet will just run after that. The provisioning steps are in order, so we can have multiple provisioning steps. And then, yes, our Puppet will run. Another nice point about the multiple provisioning steps in this is because Vagrant does allow you this, you can have multiple Vagrant, you can have multiple shell steps, even multiple Puppet steps. It does allow Vagrant to combine different Vagrant files. So we can have this is how to set up a dev environment Vagrant file. Then each developer can also have their own Vagrant file in their home folder in .vagrantd. And this will then get applied first. So if that developer wants Emacs or Vim, we can have that all set, they can have their own custom configuration. That will get run, choose however they want, and then this file will get run. So then we're not having to have, for every single dev environment, install Emacs, or every dev environment there, have every single user set up. So this kind of leaves us with our /vagrant directory with our various folders for the repo that would be a normal coding thing. And then at the bottom, we've got our Puppet directory. We've got our manifests, our modules, which is not a checked-in folder that's created. The vendor, that's the cache folder where Librarian Puppet sticks all the modules in zipped up format. And then our Puppet file and our Puppet file.lock, that's the file that gets automatically created and keeps all the versions. And then that basically now means we have a nice self-contained dev environment. Everything's within the repo that they need. There's no going off looking in other places. It's all within one repo, all checked in, version controlled, no horrid readmes and Word docs to go through. So that's basically Vagrant covered, and anyone who's not used it, I'd really recommend trying it out. Very easy to get set up. Next thing I'm going to talk about is Docker. And again, I'll go to its website and build, ship, and run any app anywhere. So, Docker, once you've used Vagrant, Docker is actually quite similar in some ways. So, basically, we have a Docker file, like a Vagrant file. Different syntax, but again, we want to start from an Ubuntu image, we want to update it, we want to install Apache, we want to expose port 80, and then we want to run, when we spin up, we want to run Apache in the foreground. So Docker is similar in a way to Vagrant, however, it's not creating an entire virtual machine. It's based on very new Linux kernel features, which is very similar to chroot, when you chroot a process and it can only see part of the operating system, except instead of just the file system, it's everything. So this can run, even if we have another port 80 running, you can have multiple of these running on one boxes. It will spin up separate instances. You can sort of restrict processor, you can restrict RAM, It is like it's an entire virtual machine, except it's got a lot smaller footprint and a lot smaller size. It does share the kernel with the base OS, so that's the main thing that gives its smaller footprint and speed advantages. So, once we've got our Docker file, we can build it. So, Docker build, tag it as demo, using the current directory, and it will start, again, downloading all its dependencies. Again, it will cache things like Ubuntu downloads and many screens of console output later. You'll be able to go sudo docker images, and you'll see, yes, we've got at the top our demo, which is tagged as latest, and then we've got our Ubuntus, and although it's tagged as multiple things, you'll see their IDs are the same. So people can name it different things. Latest, you can just say, I want the latest Ubuntu, I don't care which version of Ubuntu it is. And then finally, once we've got an image, we want to run it. So sudo docker run, demonize demo, give us a unique ID for this running instance. And if we do sudo docker ps, which is basically list all the running containers, then you'll see it's got its container ID, it's the, oh, this is not from the demo, but the image name, what command is running, and various other things that are off the side of the screen. And this is then very much like a running virtual machine within its own sort of system. One disadvantage with Docker at the moment is it doesn't run natively on Mac. However, there's a program you can download where it basically runs Docker within a virtual machine. For these, I've been running it within the Vagrant file for when developing. I know they are trying to basically work on this, and this is kind of, and also bare metal Docker runners. So, very similar to the Vagrant stuff. And this is what makes it the two projects I find particularly nice to work hand in hand. So, from Ubuntu, we want to copy our Puppet directory to the server. We want to change into that directory. We want to install, again, Librarian Puppet, run Librarian Puppet, and then Puppet apply, and then clean up after ourselves. And so, again, we've got a nice little machine with Puppet installed, Librarian installed, and we can then easily run some Puppet scripts. So we can now have our Vagrant file, where we have, say, our Puppet with our various modules, and we have, say, different environments or different files. We've got a development one for our Vagrant, we've got production for our Docker. And I think for anyone who's not heard, has everyone heard of the 12-factor app? Basically, it's a document online about a way of creating apps which are self-contained and you don't have interconnecting dependencies. It's very much connected to Heroku and the way they run things, but basically it's a collection of things that says an application mustn't rely on any certain software, or it must be configured via environment variables. This makes things very easy to run in multiple places, very easy for people to configure. For example, if a developer creates something and then a sysadmin then needs to configure what the host name is or how many instances are running. And this is where Docker becomes very powerful. Basically what Docker has now given us is an image that is being built, which is like a virtual machine image, but much smaller, some of them only 100 meg, including its entire OS, which is then easy to distribute, deploy, and run. This means, for example, when first setting up a server, especially if you're compiling things from source, this can take a long time. Just downloading the Docker file is much quicker, and especially in, for example, like Amazon scaling instances, when you want to just bring up instances for an hour, bringing these up is much quicker and will save lots of money and time. And also configuration and all this kind of thing is brilliant. I don't want to go into too much detail on that, but if you don't know what the 12-factor app is, worth a little read of that, and it's kind of good principles to adhere to for any application, really. So once we have this Docker file, we can run it locally with Docker run, for example, and test it. It will be exactly like our production environment, but we can configure our environment variables, say our host name or which SSL cert to use or only one instance. We can then run this Docker file on our infrastructure, and there's a number of ways we can do this. As explained in the first talk, I believe, is Puppet now, the Puppet module, you see a nice little approved flag there. This is an extremely good module for Docker. You can then have on your server you can then have lots and lots of servers which are basically configured very similar, basically just running this Docker. And then we can say, for example, our web servers. I want to pull down our web app image and run it. I want it with these environment variables, maybe configured from here or configured from wherever the sysadmins want to. And it also nicely splits up the kind of different role between developer, sysadmin. Yes, and then the Puppet module can then run that, ensure it's running, restart it when it's updated, and manage it all that kind of way. Another quite nice thing for running Docker containers is Amazon Web Services. Their Elastic Beanstalk has recently added Docker. For those of you who don't know, Elastic Beanstalk is basically it uses Amazon infrastructure, but it's basically a pre-built configuration they have for spinning up a system automatically. So in that drop-down they have things like, I want a Rails app, or I want a insert X here, with various things. The advantage then with the Docker is, rather than the limited kind of set of apps they have, you can just run a Docker container. And in that Docker container can be whatever it wants. It doesn't matter. So we can just then upload that to Amazon. It will do the auto-scaling. You can configure it through Amazon. And yes, and then monitoring and things as well. So again, it's a very nice way of just shipping this self-contained, not have to worry about it. The other advantage with all this is we've got our configuration, our code, for both our development and production setup, and our actual code for the app, all in one repo. It's all self-contained. This is especially useful for, say, very small applications or open source applications where you want to say, go to my repo, the readme is Vagrant up, Docker run, everything's there. You don't have to say in your readme, this works on Ubuntu 64 bits, you must have this. It also means that all our Puppet code is checked in with our application code, so it's easy to manage versions. So if a new version of the app, if suddenly requires this package, it's all part of the same commit, it's all then deployed at the same time, it's also built at the same time, and if it's problematic, it can be rolled back at the same time. This method can work with a lot of companies. However, a lot of companies might be thinking, no, we already have a separate repo full of lots of Puppet code, or we might, for example, want every single one of our 100 apps to have this package installed or something configured on it. So another thing that both Vagrant and Docker support is their base images. So both our examples here, we used Ubuntu as the base image. Both of them, so if we go to the Vagrant public boxes, we'll see there's lots of other ones other than Ubuntu. You can find all sorts of like pre-configured Apache setups. Docker has something very similar. So these are basically pre-built, pre-configured things. So for people who are maybe not knowledgeable of something, this is a good way of publicizing your app and getting it up and running. So I just want an Apache running. I don't, or some of them are more full stack Apache with PHP and a database all in one container. The other advantage of this is they both have public repositories for all this. We can also push our images to private repositories. They both support, say, Amazon or a local file system. So what we can do with both of these is, say, every single one of our dev machines in all our dev projects have Project X installed. We can create a base image, say developer base image, checked into our code repo, say our server config repo, which is where all our Puppet code is, and then publish our base image. Then each project can then have its Vagrant file to then pull from these images, and then in that project there can just be the stuff specific to configuration that project. Or if we really want to completely separate the dev role and the sysadmin role, and they don't want to be dealing with each other's repos, we can have a separate sysadmin repo with all the Puppet code, including the Puppet code for those apps, that will then build the various containers or Vagrant files. So you might have in your Puppet repo Vagrant demo app, and then the Vagrant file in our demo app actual code repository just needs to say Vagrant bot, Vagrant demo app from my EC2 folder, and then it kind of keeps those two roles separate, especially in some larger companies where you've got the traditional sysadmin team and the development team. And then this enables us to distribute packages, and again, if you've got an open source project, you can sort of ship these up and you won't have to even worry about checking out a Git repo. Someone can just do Vagrant or Docker up and it will pull down these images from these public repos. And that is basically it. Does anyone have any questions?
Questions?
So about Docker, so do you deploy with Puppet to Docker, or do you deploy the whole image?
You basically deploy the image. So the image is built. We can use Puppet for building those images. So for example, if we have an automated build process, Puppet can say, every time the Git repo is updated, build that image, push it to the repo. Then we can also deploy with Puppet. So rather than having to build and compile all these things on all our web servers, the web servers don't have to have any of these, say, compile time dependencies. All the web servers need to do is, when there's a new version of the Docker image, pull that down and spin it up. So yes, Puppet can be used on both sides, or neither. Any other questions? Guess we're done.
Have you used Test Kitchen to do testing of your Puppet modules with Vagrant?
I've not used too much of the various testing. There's either unit testing or actually integration testing projects for Puppet. Mainly on this one because it's just a small app and I've not done that. But yes, because the Puppet files are, as you saw, just install Ruby, install this, you can then use that for running it in other places. You can just do Puppet apply on a VM. So when developing it, I'll do that, and you can do the same with testing. I believe also a lot of a few Puppet projects I've seen have actually included Vagrant files to then be able to test out a whole end-to-end solution for testing. So rather than having to, say you've got a Puppet module, spin up a web server, rather than having to spin that up on your local machine, they're part of their test. They have a Vagrant file in there and it will actually test the Puppet module. So, but yes, I've not actually done that myself on this project. I have done a few of that in company projects I've worked on, but they're not public, unfortunately. How come there?
Sorry.
Do you have an opinion on where Puppet is best used in that workflow? Because I noticed the question before last, you mentioned it can be used for both creating Docker images and deploying Docker images, but also in the actual provisioning process of Docker images themselves. Yeah. And it kind of feels like if you were to do both, you're kind of polluting the idea of Puppet somewhat. Do you have a preference for what should be used in which place?
So I think one of the main advantages of Docker is basically it creates an image. Under the hood, it's actually creating lots of images with diffs. So one of its main things is you just have an image and you deploy it. If you want to change that image, you create a new image based off that, and it will be very small. So for example, if SSL vulnerability, rather than actually installing it on all our servers, you create a new Docker image, you check it, you make sure it all works, then you ship that image. So I believe actually a running Docker container itself shouldn't have Puppet running within it and updating it and managing the inner of the container, because the idea of a container is once it's created, it's kind of fixed in time. If I actually want to spin up an old version with that, although Docker, for example, Puppet can say, oh, I want this version of the package. If, for example, that package is then removed from the repos because it is insecure, you can never then get that same state set up. Whereas the Docker images it forevermore is created and can be spun up. So actually, then creating them, I see no reason why you won't have it's perfectly fine to have a Docker build server that would do the whole, using Puppet, would do, basically, rather than having shell scripts going git pull, Docker build, all those commands, using Puppet for that obviously is very nice because, again, the kind of stepping in language learning point of view that was made earlier, you don't need to learn a whole new set of commands, you can just use Puppet, is nice, and obviously we don't want lots of shell scripts. And the whole server managing side, I actually used Elastic Beanstalk on this project, so I've not actually got a Puppet running in production, but Beanstalks, I'm only using that because it's kind of new and I'm testing out things on, in the company I work at, A, we're not on Amazon, and B, we've already got existing hardware. So we have, with Puppet already running, so it's quite a nice process of just spinning up, bringing in Docker, trying it out, and then getting rid of and using Puppet to manage that, and manage the deployment of that, and integrates nicely with our existing process. And also, we might not want all our nodes as Docker, so we still use Puppet for managing that, so on both sides, really.
Other questions? Excellent. Thank you so much, Owen.